the teams are getting more intercultural. So it's the experienced engineer with his experience of more than 20 years in hardware design, but not just hardware design, having in the team also a software expert, but having also the young talents which are coming from the maker side, and they are getting more professional. And so we see the young students coming to the trade show as well, getting in touch with us and showing what they learned and did the last years on maker boards. And we show them this is very good, this is fancy, this is very innovative. And in special requirements, you can stay with maker boards, but sometimes if it gets serious, where you need longevity of 10 years in medical projects, for example, we also have other boards and other software tools that you can use sometimes to fulfill this professional industrial world. But it's very interesting to see that you shouldn't disconnect these two worlds. They are all together in one real world, and we have to accept both worlds. We have to accept both ideas to find the best solution for the end customer. So at Congatec we are very focused on embedded computing, especially driving us computer on models. So computer on model concept is one of many form factors where we have the processor on a compact board, on a computer on model, and we are the experts there, and we like to lead this area to design new open standards with our friends and competitors in the market to bring these new feature sets, generations of technology on the board, and also not to forget, because it needs to be successful in the market and we have to fulfill the solutions of the customers, also having the other view. Having the other view to listen to immersive potential customers. What is you driving at the end? So don't be too long in your lab to test all the function and features, to bring all the technology on the board. Don't do this too long. Open up earlier, go out and test and bring your customer much earlier in the stage. So that was driving us for a new computer model standard, which is the computer model standard COM-HPC. So we bring now the high performance computing on a module standard. That means we have a computer model that is designed from Congatec, and this is connected to a carrier board. Together it's like a very special main board, and the customer is working on the carrier board where he can do his customizations and where he can stay on the focus on his device and on his end application, on his system, and we bring him a perfect new computer module. So it's again a kind of a connection from technology to market. And so it's about to listen more to the customer, to bring him much earlier in the game. And we don't do this only in an application level. We are also doing this in a level of new computer standards. So what we are preparing since around more than 6 years now is this new standard, where we had the requirements and the view from the potential market and customer side that we have requirements and a huge demand in the edge where massive of data are generated, and it's not possible anymore to bring them all to the cloud, the long way from the edge device to the cloud, where we have this secured environment for the processor, secured environment with ventilation, that they can do all the computing in the secured data center. So as an expert like Congatec in computer modules, an expert in this computer standard, where we are very close to the edge in all kind of devices, we could see, okay, what can we do at the edge to support, to bring out maybe this data center requirements to the edge because we can't transport it anymore to the data center. What can we do? So in discussions with potential customers, big customers, small customers, edge experts, data center experts, silicon vendors, for example, like Intel, how can we fulfill this together? So it's not only us as an expert in computer modules on the embedded computer level, it's also about discussions with silicon vendors like Intel, preparing this processor to take them out from the data center. What needs to be changed in this processor that he can survive in this edge where we have harsh environments, where we have extended temperature, where we have shock vibrations, where we have this industrial environment. How does the processor needs to be changed? And how does a embedded computer form factor needs to be changed to fulfill these requirements with new standards like up to PCI Express generation 5 to 6, much more higher data bandwidth, much more Ethernet connection, 10 gigabit Ethernet and more. So it was a new game, a new play of all of us in this stakeholder ecosystems to be able to fulfill this. And the new standard is now on the market, and we have first customers playing with this new computer modules and using it at the edge in a kind of an edge server, where we brought out this processor now with extended temperature range. We brought it out on a big module. We brought it into a very extreme harsh prepared chassis device box that it can survive at the edge in all kind of areas where it's hot, where it's cold, and it works to prepare to compute the data now at the edge, as we have massive data there. It is really exciting because now we are getting the tests and experience of our customers, because now they are starting to work on their own carrier board. So in the model concept, they start with a starter set from us, where you get a computer module, where you get a new cooling solution to cool this Xeon processor with more than 100 watt TDP. And they were playing with our evaluation carrier board in the lab, where you can test everything. And now they see which requirements they have, and they start to develop their own carrier board, and they make it smaller, they shrink it. They just start to use the functionalities they use and need for their special edge server or their special micro base stations for 5G, private 5G. So now the first models are out, and we are getting feedback and learning again how they are playing out in the world now. And it's so excited because I think we did a good job the last years.